So those are the basics behind the ways in which we use liquids to increase de-icer efficiency. I want to spend the rest of our time this morning talking about the differences between the various liquid options that we have. And at the outset, I want to point out one challenge to this. Predicting precisely how chemicals perform in the field is challenging. And that's because there are a variety of factors at play in the field that interact with each other in complicated ways. And we are currently working on trying to develop some better test methods that will simulate the various types of conditions that occur in the field so we can better understand how different chemicals perform under these conditions. But for the moment, I think the best that we can do is to focus on the basic performance characteristics of the various chemicals. And I think by doing that, we can get a general idea of their relative effectiveness. So de-icing chemicals basically work by two fundamental mechanisms. They either act as an anti-freeze, where they prevent precipitation from freezing on the pavement, or they act as ice melters by actually melting the ice. And since ice melting has got the most obvious, direct, intuitively easy to understand relationship to effectiveness under field conditions, I'm going to focus primarily on ice melting. So, how do we make ice melt? How do de-icers work in the first place? Well, there's the obvious way to melt ice, of course, and that's to heat it up. So let's say this is your outside temperature. And let's say this is the freezing point of water. Now, if the outside temperature is below the freezing point of water, of course we know we're going to have ice. So the obvious way to melt ice is you heat the pavement up above the freezing point of water, and it will melt. Well, unfortunately, that's not a practical way to melt ice on hundreds or thousands of miles of roadway. So we use chemicals to do a nifty little trick. Since we can't heat the pavement up above the freezing point of water, we apply a chemical that lowers the freezing point of water below the outside temperature. And it amounts to the same thing. Whether we heat the ice up above the freezing point or we lower the freezing point below the outside temperature, the ice is going to melt. And this is how all chemical de-icers or chemical ice melters work. They all work exactly the same way. They work by lowering the freezing point of water. So this diagram here shows you what the molecules look like in liquid water. In liquid water, those individual water molecules are in free motion. They're not stuck together. They're able to freely tumble and roll past each other, and that's what makes a liquid a liquid. It's why liquids will flow. Now, when we freeze water, what we do is we pack those water molecules together in this very tightly packed arrangement, where it's all tightly packed together. Now, if I dissolve a chemical in water, essentially what I'm doing is I'm introducing foreign particles. Those foreign particles will get in the way of the water molecules, and they make it more difficult for it to pack. So we have to go to colder and colder temperatures to force that packing to occur, and we end up lowering the freezing point. So all de-icers work by the same principle.